We look on to the next part, this familiar diagram, okay, consisting of points A and B having coordinates x1, y1, x2, y2 respectively. Okay, they are joined by a yellow color line as I have displayed. And if you observe, we have formed this right angle triangle before. Okay, I call it ABC here. Okay, and angle C is 90 degrees. Okay, now what we will do is we'll extend the line segment AB. Okay, and you can observe that an angle is being formed here, right? The angle theta. Okay, so this is angle BAC. This का measure is an unknown value which is theta, let's say. Okay, now we are going to prove this anyway. Okay, when you extend this, okay, you get this complete blue line here. Okay, this line also makes an angle theta with the positive x-axis. Okay, anyway, we are going to prove this in geometry when we study corresponding angles. So by the property of corresponding angles, this angle also is theta, right? Now this angle theta, it is called as the inclination of the line. Okay, inclination means the angle that the line makes with the positive x-axis. Okay, so we already have observed the differences here. Okay, differences means the difference of the x coordinates here, which is x2 minus x1, which is the length of this side of the right angle triangle. Okay, when we study distance formula, we derive this. And same way we can find out the length of side BC basically. Okay, which is y2 minus y1. Okay, now we'll apply some basic trigonometry. Tan theta we'll find out. Tan theta for any right angle triangle is the ratio of the opposite side to the adjacent side. Okay, so tan theta is nothing but BC divided by AC. Okay, now putting the values, you get tan theta as y2 minus y1 divided by x2 minus x1. Okay, this is called as the slope of the line. Okay, tan of the inclination of the line, basically it is the slope. Okay, for any line, this is going to be universal. Okay, the slope, that is going to be tan theta, tan of the inclination, or it is nothing but the difference of the y coordinates upon difference of the x coordinates for any 2 points. Okay, now guys, you can remember this as a standard. Okay, actually it's pretty universal. Okay, whenever you take a straight line, इस straight line के across कोई भी 2 points अगर हम लेंगे, okay, let's say they have coordinates x3, y3. Okay, and the second point has coordinates x4, y4. Okay, इन दोनों का अगर हम slope निकालेंगे, okay, which will be y4 minus y3 divided by x4 minus x3. Okay, this slope will be same as tan theta, which was y2 minus y1 divided by x2 minus x1. Okay, so this is a property. Okay, this is a universal property of any straight line, guys. Okay, whichever 2 points you find on, whichever 2 points you take on the line, you calculate the slope will always be constant. Okay, now this is something which you can remember. Okay, that 2 points. Okay, whenever you have 2 points, okay, when you join them, you are forming a straight line, right? So whichever direction you extend them in, either this side or this side, okay, you'll be generating one straight line, and the straight line will always have a constant slope. Okay, the second takeaway from this is that any straight line, okay, linear equation, basically we have seen this in linear equations when we saw them, simple equations wale part mein. Okay, for any straight line having equation ax plus by plus c is equal to 0, the slope is minus a by b. Okay, this happens because, okay, whenever you have the slope of the line m and the y-intercept, let's say k, then the equation of the line becomes y is equal to mx plus k. So comparing it with this, okay, changing this ax plus by plus c in this form, okay, you will observe that y is equal to minus a by b into x. I'm just changing it into this form, minus c by b. Okay, so by comparison, the slope m is minus a by b, you can see here, and the y-intercept, we'll talk about this in detail in some time, is minus c by b. Okay, so let's put this to use. Okay, before that, let's understand, guys, अगर 2 points है हमारे पास, okay, okay, if we have 2 points, okay, and if we calculate the slope in between them, okay, the slope, as I said, will remain constant. अब अगर कोई तीसरा point होगा, okay, जो इस line पे lie करेगा, right, उस तीसरे point का भी slope क्या होना चाहिए, same होना चाहिए, that we calculated for these 2 points, right? So again, I'll reiterate, okay, n number of points you take on the straight line, you calculate the slope between them, the slope will always remain constant, and this is the property, this is the very basis of forming a straight line. Okay, the basis is that the slope will always remain constant. Okay, going on further, find whether the following points are collinear or not. Guys, first question is 2, 3 and 5, 6. देखो, for forming a straight line we always require 2 points, right? तो अगर ये 2, 3 है और ये 5, 6 है, when you join them you always get a straight line. So 2 points, guys, are always collinear, right? There is no need to check as such, right? So for the first question, the answer is yes. Okay, suppose if I have a system of 3 points, okay, 2, 3, 5, 6 and 0, 1. Okay, अब हमें check करना पड़ेगा, right? Because 2 points may be collinear, they may have a slope, but the third point, maybe if it is here, ऐसा हो जाएगा, if it is here, तो ये ऐसा हो जाएगा, third point. अगर एक तीसरा पॉइंट इधर है तो ये ऐसा हो जाएगा, they might be, three might be collinear, right? So for 3 points basically we need to check, okay, whether they are collinear or not. How do we do that? Out of these 3 we pick out pairs of any 2 points. Okay, let's take 2 3 or 5 6. पहले ये पेयर सेलेक्ट करते हैं हम लोग. इनका स्लोप कितना हो जाएगा? y2 minus y1 6 minus 3 upon x2 minus x1, which is 5 minus 2. Okay, 6 minus 3 is 3, 5 minus 2 is 3, 3 upon 3 is 1. Okay, इसको आप उल्टा भी ले सकते हैं, मतलब you can write 3 minus 6 and 2 minus 5 will give the same slope. Okay, now let's check the slope of the second and third points. Okay, 5,6 and 0,1 will be 6 minus 1 divided by 5 minus 0. This comes out to be 5 upon 5 equal to 1. The slope is same, right? Okay, इसका मतलब the first 2 points when you join them, जो भी line बनेगा तीसरा वाला point उसी पे lie करेगा, right? So answer for this question also is yes. Okay, okay, the points are collinear. Alright, so 3 points अगर हैं और आपको check करना है कि are they collinear or not, take any 2 pairs of points. Okay, check their slope is equal, points are collinear. Okay, next question is 2 3 5 6 8 10 10 12. Oh, there are 4 points now into consideration. Now यहाँ पे guys सिर्फ 2 pair of points का slope निकाल के equate करके नहीं चलेगा, right? Why? Because there might be a chance that the line formed by these two will have some slope, let's say x units. Okay, and the line formed by these two will have some slope, let's say y units, and the line formed by these two will have some slope z units. Okay, तीनों का equal होना, okay, is necessary that all 3 points are collinear, right? So we don't need to check pairs of 2 here, 2 pairs here. Here we will need to check 3 pairs of points and find their slopes. So guys, for 2 3 and 5 6 we already found the slope in the previous question, which was equal to 1 unit. Let's calculate the slope for 8 10 and 10 12. Okay, for these 2 points slope कितना होगा? 12 minus 10 divided by 10 minus 8 equals to 2 upon 2, which is nothing but 1. So एक बात तो तय है, 2 3 and 5 6 को मिला के जो भी particular line मिलेगी, okay, उसका slope same है with the line formed by 8 10 and 10 12. Okay, now last thing is whether the slope between these 2 points 5 6 and 8 10, is this slope equal? If this slope becomes equal, that means all the points are collinear. If not, that means we have 2 set of collinear points. Okay, so let's calculate slope for 8 10 5 6. I'll do the reverse now to demonstrate. 6 minus 10 minus 4, 5 minus 8 is minus 3. Minus minus cancel, the slope is 4 by 3. Okay, that means it is something like this. Okay, slope of these 2 points is same as the line formed by these 2 points, which is different than the slope formed by these 2 points 5 6 and 8 10, right? Okay, so from here guys we understand that whenever we need to check the collinearity, we will always use the condition for equal slopes. Okay, okay, corollary ulta, whenever slopes are equal you can always say that the points are collinear. Okay,